The next thing we're going to talk about is how we copy values from a class to another class. Or rather, how do we copy an object to another object? Uh, this is part of the basics of how we define classes, and it's really important that you understand how this copying works. So before we get started, I want to ask you all a question. When you copy a class, or rather when you copy an object and that object reference, should it copy the values of that object or should it copy the reference? What is it that we are actually interested in copying? Do we want to have two pointers to the same object, or do we want to have two objects with the same values? So in the default copy, the only thing that happens is we copy the reference. So remember, everything is a reference to an object, and think a little bit about how you used pointers in C++, right? The variable names that we have for objects are essentially just a pointer to a reference location that has the values of the object. We're not pointing to an individual set of values, we're pointing to a memory location. If the object, if the object A is a copy of the object B, and the class has no copy method, meaning that we didn't define a way for these things to be copied, and we set A to B, right? So new object A equals old object B, then A is not a copy of B's values. Instead, A is a copy of B's hash, or rather, A is a copy of the reference to that object. So they're both going to be pointing to the same object. Now changes to A will also change B because changes to either of them are actually changes to the one memory location that they're both pointing to. So if we want to actually copy the values, we're going to do this using a copy constructor. So what's going to happen here is you're going to define a constructor that takes a object of its own class as a parameter. All right, and this then is going to define how values get copied into the new object. Deep copies may sometimes be needed when you have a class that contains other class types. That's called a has-a relationship. So deep copies may be needed when you have multiple layers of custom classes. And it's important that you make sure that you're copying things correctly. Deep copies share no references with the original other than immutable type references. An immutable type is something like a string. Whenever we declare that the string has changed, it doesn't actually change the string. It creates a whole new object that has the new string information. So that's important to remember. Deep copies share no references with the original other than these immutable types because these immutable types are immutable. They can't change. And any other type of copy is considered a shallow copy. So make sure when you're creating your copy constructors that you're doing it in the appropriate way. I almost always recommend that you do deep copies because it makes sure that your objects behave the way people typically expect them to when you create a copy. So when do you want to use a copy? You want to use a copy when we're returning object values via getters. So if we're returning primitive types, that's not a big deal. We don't really worry about that. But if we are returning an internal object from our class, maybe for example, we have a employee directory class and we're wanting to return a specific employee out of that class, we want to actually copy that employee because if we return the original employee, what's going to happen is while we might not want them to be able to set values on that particular employee, if we return the original employee object, what's going to be able to happen is they can modify that object on their program on their side and it update that employee's values in our storage of that employee. So make sure that you're returning copies of objects in this case. The second is creating a second object with similar values. So for example, if I have a shape like a circle and I want to create a circle that looks identical but is technically a different object, this is when I might use that as well. So we'll go over an example, a small example of what this looks like using arrays as our primary type that we'll be working with in the next video.